Now, in this video, I am going to explain about some very important topics, and the first one is ozone, O3. Now, we'll see the preparation of ozone. So, ozone is prepared by passing the oxygen gas. So, through ozonizers, it is prepared by passing pure and dry. Pure and dry means it should not contain any impurities or water vapors. Through ozonizers. Ozonizers are the instruments which are able to convert oxygen into ozone with a mixture. They do not produce pure ozone, or any instrument, any ozonizer cannot prepare or produce pure ozone, but the ozone mixed with oxygen. So, here there is some structure, see here, and there is this type of structure, and from this we get the ozone mixed with oxygen. This is the inlet for the pure and dry oxygen, pure and dry oxygen. These are the limbs of ozonizer, limbs of Siemens ozonizer. Ozonizers are of different types. This is Siemens. It is a Brodish ozonizer also, so they have some slightly structure difference. So this is the simplest way. It is made up of glass, and it is made up of glass. Hard glass rather, and it is having the plates of metals like thin plates, and the current is passed, left is plus minus, and there is the passing of silent electric discharge. Silent means there should not be any sparking, there should not be any fluctuation. Otherwise, direction is very, explosive. And so, as a result, we have O2, and here there is silent electric current. Silent means there is no fluctuation, regular and steady voltage. So this is leading. So there is the formation of the ozone, and so this ozone, it is further processed to get pure ozone by fractional distillation. Fractional distillation of what? O3 plus O2 mixture. So it is there about the preparation. Now coming to the properties after preparation. So it is a pale blue gas, pale blue, very light blue, very rather ultra light blue. Suppose you take a glass of water and put just one drop of blue in. So just its an appearance of blue color. So that is meaning of pale blue gas, and it is violet black solid. Violet black solid and dark blue liquid. So actually these are at very low temperature, as it is highly unstable. Now it is highly unstable. It is highly unstable and decomposes quickly. It decomposes quickly, very fast, to form nascent oxygen. Nascent oxygen means atomic form. Newly born. Nascent means newly born automatically. So O3 breaks automatically, and this is the nascent. This is O2. This is nascent oxygen. Atomic oxygen, it is highly reactive. So as a result of this, it is having very strong oxidizing current. Now next property, it is having characteristic smell like that of feces. It has fishy smell, and it can be easily identified that this is the ozone. So ozone, it is having fishy smell. Now it is harmless in a small amount. A small amount means very low concentration, but at higher concentration causes nausea and vomiting. It is around 10 ppm. It becomes dangerous. 10 ppm it becomes dangerous. So ozone, it is used in many industries, and so in many industrial accidents there is feeling of nausea, vomiting. So chlorine, ozone, they are different gases which are used in industry in different ways. Now next is its chemical property. It is very powerful. It is very powerful oxidizing agent. And why it is powerful oxidizing agent? It is due to liberation of nascent oxygen. And so we can say it is thermodynamically unstable. If we keep ozone in any vessel, actually ozone is kept in form of water solution at normal conditions for hospital purposes, but even then it is kept in highly black colored cloth or paper in dark brown colored bottles, and it is due to this O3 breaks into O2 and this. So this is able to oxidize. So it is very powerful oxidizing agent. And ozone can cause iodide ions in presence of water, and there is the formation of iodine and O2, and so it is there. This is the iodine solid, and you get the violet color. Iodine is liberated. Other is, it has the application that it is able to oxidize lead sulfide, black in color, to PbSO4 again in presence of acidic medium or solution, and there is the H2O plus there is O2. So this principle is used in restoring the original color of old paintings. This principle is used in restoration of original color of old paintings. You all must know it. Colors are basically made from lead sulfates. This lead sulfate, it is having white color. Whether it is watercolor, it is oil color. Watercolor or oil color, all are made up of lead sulfate. In any color, it is basic color and it is made. So when any painting, any monument has this painting, or any showpiece is painted with this, so with the passage of time it becomes dull. Due to formation of this lead sulfate is converted to this lead sulfate. How? PbSO4 plus H2S, because H2S is produced in atmosphere by the decomposition of proteinaceous matter, decomposition of dead bodies of animals, proteins, etc. So there is formation of PbS plus there is formation of H2, SO4. So this is there, and this is the principle. Now other property, there is the doubt among scientists. It is responsible for ozone layer depletion. Ozone layer depletion is due to this formation of nitric oxide. So nitric oxide from exhaust of jet planes. It is probable theory. It combines with O3 and there is formation of NO2 and this O2, and so this is there. So this is the probable reason for this. Now last is the UGSO as an oxidizing agent. It is used as oxidizing agent in many organic reactions. So this one as disinfectant. As disinfectant in operation theatres, hospitals, etc. Then as bleaching agent for any in cosmetic surgery also it is used. Then in disinfecting potable means which can be used for drinking setting, potable water. You might have seen, if you purchase water bottles from market, it is written, it is ozonized, means the water has been processed with ozone. So this is about the ozone. Now next is sulfur. So sulfur, it is obtained from the earth crust by lowering the pipes, and through pipes the superheated water is passed, and sulfur has no melting point, so sulfur comes out, and so we will get sulfur mixed with water, hot water, then the sand, piece of stone, etc. And so sulfur is basically found in Italy. Italy has a rich source of the sulfur. Now we'll see about the electrons of sulfur. So you know entropy is the property of some elements due to which they have different forms which are chemically identical but physically they are different. So same is the case with sulfur. So sulfur has many tropes. Sulfur has many allotropes, and these allotropes are some are stable at high temperature, some are stable at room temperature, some are prepared under normal conditions by suitable method. So some are stable at very high temperature. There are approximately 6 types of sulfur: rhombic sulfur, monoclinic sulfur, plastic sulfur, catenary sulfur, sulfur vapor. So they are all. But we have to see about the 3 important points. First, rhombic sulfur. Rhombic sulfur. So rhombic sulfur, it is having the SA, it is octatomic, and it is yellow in color. It is yellow in color and stable at room temperature. The sulfur which we see in normal conditions or it is available in market, so it is called rhombic sulfur. It is yellow in color and it is water insoluble. It is water insoluble. It is not soluble in water, but soluble quietly, but soluble up to larger extent in organic solvents. Organic solvents like ethanol, benzene, CCl4, etc. And so it has particular smell. It has a particular smell. And this rhombic sulfur, it is also commonly called as alpha sulfur. It is also called as alpha sulfur. Now coming to second, it is monoclinic sulfur. And this is also having SA. It is also octatomic, and it is called as, it is alpha and it is called as beta sulfur. Alpha and beta actually they have been given due to its preparation. This is basic sulfur and this is obtained from this. So for this, the rhombic sulfur, it is heated. It is heated to get the molten sulfur. Molten sulfur allowed to cool. Crust is formed in the vessel and hole is made in the crust, and the molten sulfur is poured out. It is poured out. Then what happens? Crust is on the top. You have taken out molten sulfur by making hole. So white colored needle-like crystals of beta sulfur is obtained. So this is there, thus it is called as beta because it is obtained from the alpha sulfur. So this is called as beta sulfur. So this rhombic sulfur or this alpha sulfur, it is heated to get the molten sulfur. Then crust is formed after cooling. Crust means a layer, just like a scum. Hole is made in the crust. Suppose we have this type of Chinese crust is formed. So here one hole and two holes are made there, and so from this we pour out the molten sulfur and white crystals, needle-like crystals, they are left in the bottom. So this is the preparation of this beta sulfur. Now this beta sulfur, it is just colorless and so it is not having highly unstable, it is also stable like that of alpha, and so this is there about the alpha and beta sulfur. We will see the structure of acid molecule. So it is having the puckered structure. Puckered structure, or it is called as crown. It is called as crown shape. Puckered means there is the puckering, just like the projections, and so just here we have the 3. And here there is 2, sulfur, 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 and here. So they are connected like this. They are connected. Here we have one more, and here there is one more, and here there is 8. So this is, just like crown shape. This is crown shape structure of that. Now, in some cases, there are, by heating of the rhombic sulfur, some of this ring is broken, and so S6, hexaatomic, has chair. It has chair shape, just here, it is analogous to the this sulfur, and so here there is the, and so here there is the, this is the point, and in some cases there can be the shape, and so this 5 and this 6, so this is chair form. So this is about the structure of SA. Now, as you know, we are heating to get different, just I have said that plastic sulfur, Catna sulfur, plastic sulfur is obtained by pouring molten sulfur into water, just like it is, just like last time. Then at very high temperature on heating, further it breaks into let S6 plus S2. Now this S2, it is just 1 and just 2. It is diatomic sulfur, and it is very important to have, it has the paramagnetic. It is having the paramagnetic character, just like oxygen. It has unpaired electrons. So this is about the brief description about the allotropes of sulfur. Now next is sulfur dioxide, SO2. So it is very important compound of sulfur. So first you see the preparation. So preparation in normal conditions it is not obtained by doing so, but this you have to know. So sulfur or heating with or in presence of air, there is the formation of sulfur dioxide gas. This is theoretical portion, but this is not in general condition. Second, if you take any sulfide, let it be sodium sulfide and plus HCl aqueous, there is formation of this NaCl plus SO2 plus H2O. So this is there. This is the theoretical method, or you can say laboratory method, but on large scale or industrial method, it is obtained by product. It is obtained as a byproduct during the processing of sulfide ores. Byproduct during processing of sulfide ores or pyrites, etc. Any sulfide ore, take the case of iron sulfide. Iron sulfide on heating there is formation of iron oxide plus there is formation of, so this is there about the preparation. Now coming to properties. So as you know, it is a colorless gas. It is a colorless gas having pungent smell. Pungent smell. It irritates our nostrils. It irritates our vocal cords. It irritates our nostrils. It is highly soluble. It is highly soluble in water. It is highly soluble. When we pass SO2 through water, there is formation of S2SO3. This is sulfurous acid. So this is about the general description about the properties of the sulfur dioxide. Now coming to some chemical properties. So this is also one chemical property. Other chemical property, as you know, it is having the acidic character. So it will react with the bases to form salt. So let's take the case of NaOH plus SO2. Then there is formation of Na2 SO3, sodium sulfide. Then this sodium sulfide, again SO2, in presence of water, there is formation of Na SO4. Sodium bisulfate is obtained. So this is the neutralization action. Then it reacts with chlorine. It reacts with chlorine gas, and there is formation of sulfuride chloride. So this is formation of SO2Cl2. This is sulfuride chloride. So this is there. Then SO2, it is oxidized by video-5 catalyst 1100 Kelvin, and there is formation of SO3 in the preparation of sulfuric acid. This SO3, this is catalytic oxidation. SO2 gas in presence of oxygen, then at high temperature 1100 Kelvin, and this V2O5 metal in high oxidation state, there is formation of SO3 in the preparation of sulfuric acid in contact process. This acts as reducing agent in aqueous condition. So it acts as reducing agent in presence of water. In presence of what? Like if you take here ferric ions plus in presence of acid and SO2, this is aqueous, and so this is oxidized to, this is brown color. This is brown color. This is light green, and so this is there. So brown color is discharge of brown color. Similarly, it can also convert this MnO4 purple color, and in presence of basic radium SO2, and there is formation of Mn2 plus. So this is purple and this is colorless plus S2O plus SO4. Here also there is SO4. So it is there. It reduces other, and itself it is oxidized. Now in the last part, uses. So it is very much important in refining of petroleum. Crude oil is refined by SO2. Then other very important as anti-chlor. Anti-chlor means remove removal of chlorine. Removal of chlorine. Removal of chlorine. So in many industrial processes, chlorine is produced in excess quantity, or it is produced as a byproduct, so it is removed. Then in disinfecting, non-living things, like the vessels of pickles, vessels of sausage, tomato ketchup, etc. They are sterilized because it is having acidic nature. So it has a germicidal character also, and germicide. Then in preparation of sulfides, many sulfides by sulfate. So different chemicals they are used. Then it is used as solvent in liquid form. Meaning is SO2 liquid. SO2 liquid, it can be compressed into liquid. So it is used as solvent in many chemical reactions or study of many things. So this is all about the sulfur dioxide.